Hey, this is Mr. Ng going over the Precalculus Chapter 4A test, so basically the non-graphical part of trig. Non-calculator side, it's taken on February 21st, 2018. The non-calculators were out of 34 points. Question number 1 just asks you to fill out the unit circle. I have the order pairs going around. I also have degrees and radians and the quadrantal order pairs. You got a -1 if you missed the negatives or positives. -1 if you messed up on the radians, and another -1 if you messed up on the degrees. If you need a video to figure out how to do the unit circle, I have some on my YouTube channel, so watch. Number 2 says, evaluate -4 times cotangent 7 pi divided by 4 minus 2 times cosine at 0 degrees. So if you notice, I have both degrees and radians here. So if you go to your unit circle and locate 7 pi over 4, on the 45s, that's 1 pi, 3 pi, 5 pi. 7 pi over 4 is here in quadrant 4. And you're looking for cotangent, which is x over y. So you're taking all of the x coordinate all over the y coordinate. So this whole expression, radical 2 over 2, divided by negative radical 2 over 2 is just -1. And that's how I got -1 here. Cosine at 0. Here is 0 degrees, cosine is 1. So you just put a 1 there. If you got one of these correct, you got 2 points. Noted by my answer key here. There you have multiplication, so that's -2 times 1, which is just -2. And over here it's -4 times -1, which is +4. And then 4 minus 2 equals 2. If you make a basic mistake, then you lost a point. Alright, the student here tried to put the radians and degrees, which is fine. This one they canceled out, put 0, incorrect. They tried to draw either circles. That's fine. Remember, you're trying to figure out your, they knew cotangent was x over y, but again, they missed both of those, so it's incorrect. Here's an example. They got partial credit, 2 points for knowing that was just 1. Here's an example of a 4-pointer. They knew that tangent was y over x, so cotangent would be x over y. They took the coordinates, got -1 right there, and then got cosine of 0 is 1. Multiplied, then subtracted, that's full credit. Question numbers 3A, B, and C was just meant to know if you can either draw the triangles or just use your unit circle. So cosine, or sine at 11 pi over 6. 11 pi over 6 is in quadrant 4. Sine is cosine and then sine, so that's the second order pair, which is -1/2. Tangent of 270, that's a quadrantal, so 0, 90, 180, 270, and then tangent is y over x, so that would be 1 over 0. Your answer is undefined. Cosecant at -11 pi over 6. You don't have a positive angle here, so you're going to have to find a coterminal angle, which means you're going to get an angle between 0 and 360, or 0 and 2 pi, so you just add a full rotation there, and you get cosecant of 11 pi over 6. 11 pi over 6 is here, and there's the order pair. Cosecant is r over y, so you're going to look for cosine sine. Sine is y over r, so that's -1/2, but you just take the reciprocal of this, and you get -2. So each of those were worth 2 points. If you got some part aspect of it, you got 1 point. Here's a mistake. Getting tangent at 270. This person didn't know their x, y's, and r's for tangent. Tangent they thought was x over y, which would have been cotangent. Incorrect. That's where they got a 0. Some correct work of the student getting all 3 questions correct. Not sure what the student was doing here. I think they were trying to convert the radians into degrees to give them some kind of idea. Yeah, none of these questions were. Question number 4 is multiple choice. Convert the angle in degrees to radians. Express the answer as a multiple of pi. Awesome proportion is radians over 2 pi equals degrees over 360. So part over whole equals part over whole. They give you 30 degrees here. Factors of 30 are 30 and 1. Factors of 360 are 30 and 12. So your GCF there is 30. You have radians over 2 pi equals 1 over 12. Cross multiply, you'll get 2 pi equals 12 times radians. Divide by 12 on both sides. And reduce here, you get radians equals pi over 6. That side was worth 16 points. Backside was a free response. Make sure to show all your work to get credit. Leave all your answers in simplest radical form. Box your answers. Question number 5 says find secant of 600 degrees. Give exact value. So the word exact should tell you fractions. 600 degrees is too big. It's not a number between 0 and 360. So if I find a coterminal angle by subtracting 360 degrees, I need to find secant of 240. So if you go here, I drew the x and y axis. And so 0, 90, 180, 180 plus 60 more. Right here, this is 240 degrees. That's 240 degrees there. I have 60 degrees here, so opposite of 60 degrees is the radical 3, but remember it's going down, so that's going to be a negative radical 3. And then your x value is across the 30, so there's a 30-degree angle down here, so across that is the 1. But remember, it's going to the left, so that's equal to, x is equal to a negative 1, and then your radius is across the 90-degree angle. So secant, you need r over x, so your r value is 2, and your x value is negative 1, so you have negative 2. I gave you partial credit by giving you 2 points if you found out that you found 240 degrees is the coterminal angle, or the triangle is in quadrants 1, 2, 3, quadrant 3. And then a common mistake here was I gave you 3 points if you wrote positive 2. Here's some student work where the student thinks they're trying to go from degrees to radians, not what I asked for there. Student got to 240 degrees but didn't know what to do there. Cosine. Maybe they were trying to take the reciprocal of the wrong order pair, so definitely look at your unit circle there. Person used the reciprocal identity, secant equals 1 over cosine. They're using the correct order pair there, just negative 1/2, and you just take the reciprocal of that. Did not even need to do the rationalization, but you still got the correct answer. Question number 6 asks you to find tangent and cosecant given that a point, negative 2, negative 1, is on the terminal side of the angle in standard position. So here's standard position, and we go counterclockwise until we get to an order pair, negative 2, negative 1. So negative 2 would be left 2, down 1. So we're here again in quadrant 3. So if your x value is negative 2, your y value is negative 1, you can use the Pythagorean Theorem, r squared equals x squared plus y squared. X value is negative 2, y value is negative 1, square it. A lot of students struggled with just simplifying here. You're going to get r squared equals 5, and then if you take the square root of both sides, then you get r equals the square root of 5. So if you got both of these incorrect, but you found r equals the square root of 5, it give you 2 points. If you made 1 to 2 mistakes, such as maybe you put a negative 1/2, tangent is y over x, so that would give you negative 1 over negative 2, which is a positive 1/2. Cosecant is r over y, so you get radical 5 over negative 1, so positive divided by negative gives you a negative. 0 mistakes gives you full credit. Let's look at some student work. Here the student wrote down the order pair and labeled it x, y, but I decided to give that. It wasn't really an attempt to give it 0. Here's an example of a student incorrect simplifying there. 2 squared. 4, 1 squared should have been 1. So in this problem, I decided to give the student 3 out of 4 because they got at least the 1/2 right. Right here, this is their incorrect mistake. The student also recognizes not using the x, y's, and r's. They're still kind of using the basic opposite adjacent hypotenuse. You could use that, but you can recognize that it's hard for you to get your x, y's, and r's for cosecant. Question number 7, find the angle of smallest possible positive measure coterminal with a given angle. So I need a number, smallest possible means a number between 0 and 360, and it should be positive. So if I subtract 360 there, I get 337 degrees. Partial credit, if you wrote down the equation, 697 degrees plus n times 360, where n represents the number of rotations. Positive rotations means counterclockwise, or -1 rotation means the clockwise direction. Here we see a student struggling just subtracting. They do recognize they need to subtract 360s, but decided to give them a 1. Here's an example of full credit. Student use the formula, 337. Question number 8, last question on the non-calculator side. Find sine given that cosine of theta is negative 3/4 and theta is in quadrant 2. So if you know you're in quadrant 2, cosine of theta is x over r, so your x value doesn't really matter. One of these has to be negative. Well, you're going to have to discern that x has to be negative because your r value is a distance and it'll always be positive, so x is equal to negative 3. So left of negative 3, r value is 4. Again, use the Pythagorean theorem. Next chapter, you'll be able to use the Pythagorean identities to figure this out. And so if I have this value here, I need to figure out that y side. So r squared equals x squared plus y squared. There's a Pythagorean theorem using x, y, and r instead of a, b, and c. R value is 4. Your x value is negative 3. Remember, this means negative 3 times negative 3, which is a positive 9. 4 squared is 16. Subtract 9 from both sides. Y squared equals 7. Y equals the square root of 7. Remember, you're ignoring the negative because it's going up there. And then you're looking for sine, which is y over r, so that'll be radical 7 over 4. I don't know why I wrote that. Positive radical 7 over 4. Remember, it's positive because all students take calculus. That double checks that sine and its reciprocal cosecant should be positive here. 2 points if you knew it was in quadrant 2, like you drew a triangle here. 3 points if you kind of made a subtraction sign. Let's look at some work. Here's some student work. See, they canceled their squaring, so that should have been 16 to 9. It's hard to figure out what they're doing. Okay, they're trying to figure out that cosine is adjacent to the hypotenuse. Yes. Obviously, we're in the wrong quadrant because it says quadrant 2, not quadrant 3. Adjacent to the reference angle is negative 3. So if they understood that the reference angle was there inside the little angle there, adjacent would have been negative 3 here. At least that would have helped them a little bit. Another mistake on simplifying there. At least it was in quadrant 2. Gave them 2 points partial credit. Not sure what the student was thinking here. I don't know how they got 7 pi over 4. Maybe they looked at the friends part paper and got something close. It's interesting that the answer is 7 pi over 4. In the last student work I showed you, they got 7 pi over 4. So maybe they thought the radical sign looked like a pi button. Remember, it's really easy to tell if you know what you're doing based on the work I have here in quadrant 2. Good. Show me the Pythagorean theorem. Radical 7. Good. Give the student full credit. Alright, going over the calculator part, the bright orange paper, that was out of 26 points. Question number 9 says, fill in the blank, use your calculator to find the following. Give ratios. Okay, ratios are just 2 sides to 4 decimal places. And angles, right, it tells you you're trying to find an angle. Angles are measured in degrees and radians, right? If you're trying to convert, that'll be to the nearest tenth. That'll be 1 decimal place. So for example, tangent of pi over 6 is a ratio. I know it's a ratio because you're trying to evaluate at this angle, which gives you a ratio. So if you did tangent of pi over 6, you can just put that into your calculator in radian mode. Tangent pi over 6, just press enter and you'll get these 4 decimal places. Again, you got 1 point off, you rounded wrong. And I did want to show you something. Tangent of pi over 6 is here on your unit circle, and it's y over x, so 1 over radical 3. So interesting enough, what you're evaluating is 1 over radical 3. If you didn't have a calculator, and because you have a calculator actually evaluated this, 1 divided by radical 3. Question number 2, again, is another ratio. You're not trying to find an angle, so you only have 4 decimal places there. Sine of 14 degrees, so change your calculator back to 14 degrees, and then point in 2419, again, 2 points apiece. And the last two here, you are trying to find angles. The reason why you're trying to find an angle, because it kind of tells you right here, right? A, capital A, degrees. That's an angle measured in degrees. And then theta is also measured in degrees. So cosine of A equals 0.96. So they give you the ratio. You need to find the angle. So you have to take the inverse. Here's my calculator equation. Inverse of cosine of 0.96. Make sure you're in degree mode, and then you'll get 16.26. But remember, you're trying to find the angles to the 10th. So that's one decimal place. Number 9D, cotangent theta equals 1.1249386. So cotangent is not on your calculator, so you're gonna have to use the reciprocal identity. Cotangent is 1 over tangent. But so 1 over tangent equals 1.12 blah 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 blah, and then put it over 1, and then you can cross multiply. Tangent of that number equals 1 times 1 is 1. And then I'm trying to find theta here, so this is multiplication, so I can divide all of that to the other side. And the reason why is you're trying to find this angle, so now you take the inverse of this. So you're basically taking the inverse of, my calculator equation got cut off, inverse of tangent of 1 over 1.24. All those decimals gives you theta, and your answer is going to be 41.6 degrees. Here's showing some student work here, correct responses. Maybe this student's calculator is able to find the inverse of cotangent, I'm not sure. I accepted his full credit. Number 10 is free response. Queen Mrs. Ng is standing on top of a building, looking at a park in the distance. So top of a building, she must be pretty high, looking at a park in the distance. So the park is not floating in the air or above you, so you assume that it's on the ground. The angle of depression is 26 degrees. If the building she is standing on is 100 feet tall, how far away is the park? Round to the nearest 10th. So if you got a correct picture here, you're going to get 2 points. Standing on the building is 100 feet tall. There's Mrs. Ng, Queen Mrs. Ng, and she's looking at the park. Now, she's looking at the park there. There it says the angle of depression is 26 degrees. So again, your line of sight is this one, and then you're looking down for depression. So this angle is 26 degrees. Student who missed this question most likely put 26 here on the inside. That would be incorrect. Again, angle of depression is from the line of sight looking down at the object, down. Now, you could also say that we've already took notes in class that the angle of depression is equal to the angle of elevation by alternate angles. So you could say that one is 26. And then you can either use complementary angles or triangle sum theorem to find that to be 64 degrees. If you did 64 degrees, what's the distance from the building to the park? This side is x, and the building is 100. You do not need to find this distance here, because that's like the distance of maybe Queen Mrs. Ng is on a line and then it travels down. So from here you have the opposite over the adjacent, which is tangent of 64 equals x over 100. Cross multiply, you'll get 100 times tan 64 as your calculator ready equation. Or if you did it from over here, this would be tangent of 26 equals the opposite, which is 100 over x. And if you cross multiply there and then divide by tangent 26, there's your calculator ready equation. And you both get 205 feet as your answer. I want to show you some student work here. So I think this student recognizes that the angle of depression is equal to the angle of elevation. So they just put their 26 down here. Height of 100, they didn't identify x, but their equation is correct. Calculator ready equation, and then solve for 205. Here's some correct work. Again, angle of depression, and then its complement, which is 64. Remember, those add up to 90. And they recognize that's 26, and then the opposite of adjacent. So this is a picture that I wrote the word no. I think that student, Mrs. Ng, is not sliding down to the park. What's the distance of the slide? That'd be incorrect. The student partial credit, 3 out of 4, rounding incorrectly. So I circled the word 10th. Okay, here's a classic mistake. Angle of depression is not her looking down, it's the line of sight. Because it has to be parallel to the ground, looking to that transversal, then looking at the park. So this angle up here is 26, not this one. The reason why you know that's wrong is because if this is 26 and that's 26, that's only 52 degrees, and therefore it's not a right angle. So you need that line of sight. Help King Mr. Ng find the angle of elevation of the sun when a 7.6 meter flagpole casts an 18.2 meter shadow round to the nearest tenth of a degree. So here's your sun, and it's shining down, and I didn't label it, but this is my flagpole. It hits the flagpole. That means if you keep going with this sun ray, this area is all the area that the sun doesn't hit. That's called a shadow. So, there's the sun going all the way down. This is your shadow. Your flagpole is 7.6 meters, and you're finding the angle of elevation. So elevation is from the ground looking up to the object, which is the sun, or the flagpole. So there's my theta. So I have opposite over the adjacent. Tangent of theta equals opposite of the adjacent. And I have 7.6 as my opposite and 18.2 is my adjacent. Here I'm going to do the inverse because I'm trying to find an angle. And then when I'm finding the inverse, I have my calculated equation. The inverse of tangent equals 7.6 over 18.2. Once you put in your calculation, you get 22.7 degrees. If you have your calculated equation like this, and this is way off, I give you 3 out of 4 points. If you recognize this tangent, I give you 2. Here's an example of a student who did it the other direction. Angle of elevation here is theta, flagpole 7, and then 18. Calculated equation, kind of hard to see, but 22.7 meters. Ooh, I should actually give that one less because it's meters, not in degrees, because if you think about this, remember theta is an angle measured in degrees or radians, not meters. Ooh, that should be a 3. Alright, so this person has a correct picture. It's kind of hard, but there's the sun, shadow 18, flagpole 7. So I gave them 2 points for that, but in here they found tangent. But here, if you see it, what they did is they cross-multiplied. So remember, you're only doing cross-multiplication if you're solving for a singular variable. Now, you could, but you would just end up back getting to the same equation, like this equation. You need a ratio. So here, the student's incorrect, and remember, you're trying to, if you're like trying to solve for just something like x, then you can do the cross-multiplying there. But this here, you have a trig ratio of an angle, which is unidentifiable. You're going to have to take the inverse. Now, this one's interesting. Correct picture. They knew tangent. Pretty close. I think either the student doesn't know how to round, or I'm going to guess that they did this, which is fine. 0.42. But I think they were guessing and checking. They're trying to put in their calculator tangent of something equals 0.42, and they kept guessing, right? The hard part of guessing is you can't be precise, so I gave them a 3 out of 4. Question number 12. Brooklyn is in a lighthouse on a cliff. She observes the 2 sailboats due east of the lighthouse. The angles of depression to the boats are 33 degrees and 57. Find the distance between the 2 sailboats to the nearest foot. Hopefully you feel thankful I gave you a picture. It could have been really easy to just not give you a picture. There's your 2 sailboats. It says A and B, kind of hard to see, and then your lighthouse is on top of a cliff. So this whole distance there, if you didn't figure that out, is you have to add those. That would be 195 degrees. So this whole thing there, can't see in my print, but I'm going to see maybe C to D is 195. Just add 85 plus 110. So then, if you recognize something, 33 degrees here is the triangle and the distance to boat B. And then 57 degrees is a bigger angle, so you have a bigger angle of depression looking down. That's going to be towards the closer boat, which is boat A. Now, I'm going to talk through how I did it and then maybe show you a couple of students who got it correct in different methods. So I call the distance between boat A is X, and then this one distance is Y, so we're trying to find the distance of Y. I called the big triangle 195 degrees, 33 here, and then X plus Y is the total distance there. So I did opposite of the adjacent. Tangent of 33 degrees equals 195 over X plus Y. There I cross multiplied. And here I distribute the X plus Y, so I got X plus tangent 33 plus Y tangent 33 equals 195. X times tangent of 33, I got X from the previous problem, so let me explain how I got 126.6344 over here on this triangle, I have 57 degrees. So 57 is my angle of depression, which is equal to angle of elevation. So that just represents the x and 195. So opposite over the adjacent. Here I can just cross multiply and then divide by tangent 57, calculate a radius equation, and then I get x equals 126,634. I take that value, multiply it by tangent 33, I get 82.237. Plus y, tangent 33 equals 195. I can subtract that value from 195, I get y times tangent 33 equals 112.763. And then divide both sides by tangent 33, I got y equals 173.697. And it tells you up there to round to the nearest whole, y equals 174. Alright, so I want to explain how the student knew to find the distance between the two boats, but what they did is what they found is the distance of one triangle, there's the one, and then the two is the bigger triangle. Then they subtract the distance to get that value. And when they did that, the whole big length is approximately 300.274, which they have in the picture. And they found this one to be 126, they subtracted the two values and got the correct answer. I had to give it a 3 because they just didn't round to the nearest foot. So I like the thinking on this. A lot of students are using this one, which is okay. You can totally use it. Big minus the small to find the distance between those two. Alright, so in this problem, they're just asked to solve for the triangle round to the nearest tenth. Is that round to the nearest tenth for everything? So you just write down all your given information. Angle B is 62 degrees. C is equal to 90. Well, 62 and 90, then you just need to find angle A. All three angles of a triangle. Enter angles equal 180. Subtract 152, and then A is equal to, I can't subtract, should be 28. 28. 28. The second thing I did was then I need to find the other two sides of the triangle because I only have 25, so B equals 25. Well, you have to find, if you only have one side of a triangle, you can't use Pythagorean Theorem, so you have to use trig. So I did 62 degrees, opposite over the adjacent. I'm trying to find the length of BC. And so that gives me tangent 62 equals 25 over BC. Then cross multiply BC times tangent of 62 equals 1 times 25, which is 25, divided by tangent 62. There's my calculated equation, and I get approximately 13.3. If I know that side's 13.3, then I can use the two sides of a right triangle to use Pythagorean Theorem. There it is. You're just squaring that, 13.3 times 13.3. 25 times 25, and then I add those two together, take the square root of both sides, square root of 801.89 gives me approximately 28.3. If you got all of them correct, 4 points. 3 points if you made one mistake in here, and then you got 2 points if you made 2 or 3 mistakes. The reason why I came up with that is because if you just wrote down your 3 givens, you only had to find 3 others. And then if you found the angle one, which is easy, which I didn't do, then you can find, you could have missed those 2 and still got half credit. So here the student easily found one of the sides using trig, and then they used Pythagorean Theorem to find the other one, and all of them correct. I'm going to show you what this student tried to do, 20, 30, 25. They used trig. Let's see what their mistake was. Sine of 62, which is the opposite 25 over x. So then, if they cross multiply correctly, you get 25 equals sine x 62, correct? Divide both sides by sine 62, that is correct. And then if you take 25 divided by, that is correct. Just head around to the 10th, 28.3. There's that number we used before. Still, yeah, they would have minimized their mistake. Again, there were some rounding errors here. Remember that example I gave you guys in class about being tainted and touching things with dirty hands, right? And gets everything else dirty. Well, they did that here in rounding. And then here, what they decided to use was use trig to find the angle, which is perfectly okay if this wasn't wrong. So their numbers were slightly off. And then they should also recognize that those numbers don't add up to 180. So I gave them a 2 because there was 3 mistakes. extra credit. See how close I can get. Only do this problem if you have time. Find the value of x. Give your answer as a radical in simplest form. So here's my triangle. Notice how you're trying to solve for x over here. It's way over here. And you have all this information. You'll recognize that you should have started on the left side. You have a 30, 60, 90. In a 30, 60, 90, across the 30 is the shortest side, 1x. Across the 60 is a ratio of x times radical 3, and across the 90 is 2x. So I recognize that the value they do give me of all of them is across the 90. So 2x is equal to 10 times radical 3. If I want to solve for x divided by 2, that's 10 divided by 2 there, so x is equal to 5 radical 3. I call that variable y there. What did I do with that value? 5 radical 3, so y equals 5 radical 3, 90, half of that should be 5 radical 3. I don't know what happened here. 2x is equal to, so that means, because I solved for x here, I know I did. In my shortcut here, x is equal to 5 radical 3, and I'm trying to find the across the 60. So I have to put the x value back here, which I did. 5 radical 3 times radical 3. This will help me find the side across the 60, which is this side right here. So radical 3 times radical 3 is radical 9. 5 times 3 is 15. So on this picture, this is incorrect. This should be y equals 15. On a 45, 45, 90, now that I know that the leg is 15, the shortcut is 1x, 1x, x radical 2. So then if I put in here, this is 15, well, I just put in 15 for x, and it gives me an answer of 15 radical 2. So if you got up to 15, it give you 1 point and then 2 points for both that answer. This student used trig, which was correct only if they had used simplest radical form. Alright, so what this student did. They recognized that a 30, 60, 90 is half of an equilateral, so there's your hypotenuse in Pythagorean Theorem, and they got 5 radical 3. So that's 25 squared is 25, radical 3 is just 3. And then they used Pythagorean Theorem just to get to this side right here. And then they did it again, 15, and they know that side is also the same. So 15 squared plus 15 squared gives you 450. Square root of 450 gives you 15 radical 2. And they used Pythagorean Theorem twice and got the correct answer. Alright, so if you add up 26 points, plus this one is out of 34, then your score is out of 60. Told you guys in class you should be thankful, because if you wrote down your name plus your period for each test, that means 2 plus 2 is 4, 4 out of 60, 1 out of 15, 6 or 7% of your grade was just writing that, so I hope that was helpful for you to study for your finals. Good luck.